Yes, sir.
Okay, and we were doing the molarity questions on molarity. Now today we shall be discussing the questions on the molality. What is molality? Molality. Molality is represented by small m, and it is the ratio of, we can say that it is the ratio of number of moles of solute. It is the ratio of number of moles, number of moles of solute per unit kg of solvent, per unit kg of solvent. So what does it mean? It simply means that molality can be defined as number of moles of solute. What is this happening? Just a minute, let me close this program. Start.
Yes, sir.
The screen is visible to you now?
Yes, sir.
Okay, it is fixed. So it is the ratio of the number of moles of solute per unit kg of solvent. Kg of solvent. Okay, we have to mention here solvent
Yes,
per
sir.
kg of solvent. So molarity, small m, molarity can be defined as number of moles of solute divided by mass of solvent in kg. Mass of solvent in kg. If I write the same formula, the molality can be defined as, number of moles is WB upon WA, sorry, MB. This is the number of moles. Okay.
Yes, sir.
And it is the mass of solvent in kg. So what do you mean by mass of solvent is? What do you mean by mass of solvent? Mass of
The
solvent
total
is,
is equal to solution.
yeah, we can say that it is WA. It
WA.
is WA. Okay.
Yes, sir.
And here is, if we are just multiplying this number with thousand, because if it is in grams, because if this is in grams, this is also in grams. Okay. So we have to, since we have to convert this into kg, so what we have to do, we have to multiply this one by 1000. Okay. So that means we need to divide with 1000. So we will multiply it here. Okay. You understood? So molality can be written as WB upon MB into WA upon 1000. Okay. Now
Yes,
1000
sir.
can be written as 100 into 10.
Yes, sir.
And this, if I'm saying that this is the mass of solute upon, if I talk about this 100 into 10. Now you know that what is W by W percentage. What is W by W percentage? It is mass of solute divided by mass of solution.
Solution.
Okay. Into 100. They both should be in same unit. If it is in grams, so it should be also in grams. Okay. Mass of
Yes, sir.
solute divided by mass of solution into 100. Okay. Now, if I talk about this one, that here you can check that if I write it like this way, that this is mass of solute upon mass of solution. So what is mass of solute? Mass of solute is WA, WB.
Yes.
What is the mass of solution? Mass of solution is, we will simply say that it is uh, WB, WA plus WB into 100. Into 100. Okay. Got
Okay.
it?
Yes, sir.
Now, for a dilute solution, the mass of solute here is, we sometimes neglect it. Okay. For a very dilute solution, if when the solution is very dilute, then we can in the addition we can unrelate this one. Okay, and this can be also considered to be as for very dilute solution. When for example you are having 2 liter of solution and 2 liter of solution or 2 kg of solvent. Okay, and in this only
Okay.
1 gram or 0.0 grams of carbon dioxide is present. So when you are adding 2000 plus 0.01, so it is negligible. Okay, so
Okay, sir.
for very dilute solution, for very dilute solution, dilute solution, we can simply say that molality will be equals to this WA upon this can be considered as mass by mass percentage. Okay,
Yes, sir.
you understood? Mass by
Yes,
mass
sir.
percentage, and here we can write it mass by mass percentage into 10 upon MP. Okay, note it down, please.
Yes, sir. Noted it down, sir.
Okay, just let me have some questions over. Okay, try to solve this question. Density of 3M solution is of NaCl is 1.25 grams. Calculate the molality of the solution. So what do you mean by 3M?
The
3M
mass.
solution. No, it is not the mass. It is the molarity. When it is
Okay.
capital M, it represents the molarity. Molarity. Okay, and when it is small m, it represents the molality. Okay, and what is the difference
Okay.
between molality and molarity? Molarity is molarity. I have told you this one, teach you this one in the previous class. It is the number of
Yes.
moles of solute
Well,
per liter of solution or present in 1 kg of solution. Okay, one liter of solution. Sorry, 1 liter of solution. We can say that number of liter of solution if we are writing liter of solutions. Okay, so it is molarity.
yes.
So we will simply say here that if I'm saying that if 3M is the molarity is given, so it means that 3 moles of NaCl, 3 moles of NaCl is present in, okay, 3 moles of NaCl is present in 1 liter of solution. This means, okay, you understood?
Yes, sir.
Okay. So we'll say that 3M means that 3 moles of NaCl is present in 1 liter of solution. 1 liter of solution. Okay. So here now you need to calculate the mass of solvent because you need to calculate the molality. So what the molality? What you need to do? You know the number of moles is 3 moles in the solution.
Yes, sir.
Okay. So you have to write a number of moles. Number of moles.
Okay.
Okay. And here you have to write mass of solvent in kg. If it is in grams, then you have to multiply here by 1000, then it will be in grams. Okay. Now, first of all, for finding the mass of solvent, you need to like mass of solution minus mass of solute, minus mass of solute is equals to mass of solvent. So can you tell me, Rita, that how can you find out the mass of solution? Mass of solution. Can you find out?
Sir,
How can you find out the mass of solution from this given data that is in the question?
sir, 1.25 gram ml.
It is the density. Okay, I'm going to give you the hint. Density is equals to mass upon volume. You have to use this formula.
Okay.
So how will you try?
Sir, we can first change the number, like we can multiply the number 1.25, which is
Density, okay. With
the
what?
density, with 1000 to
Not.
um,
Okay, this is the mass. Now, if you know the density unit is 1.25 gram per ml. Okay, so you have to
yeah, so
write the volume in the ml. So how
okay,
many liter of solution we have? 1 liter.
yeah,
We are assuming this one, 3 moles. How can we consider that they are 3 moles present? Since we have considered that the solution is 1 liter and it has 3 moles. 3 m means that 3 moles of solution is solute is present in 1 liter of solution. Okay, so we have assumed that the volume of solution is 1 liter. 1 liter means 1000 ml.
okay,
Then it will become the mass. So mass of the solution will become 1250 grams. This is the
okay,
mass of the solution. Okay. Now what is the mass of solvent? You have to solute, sorry. You have to minus this one. We find this value 1250. How will you find
yeah.
out the mass of solute in the solution? How will you find out the mass of solute in the solution?
So they have not given us the solutions mass.
Okay. So you have to find out that what do you mean by the, again, I'm just saying that what do you mean by the word that the solution is 3m? This solution is 3m.
It's the molarity of the
Solution is 3. Okay, so what does the molarity mean? That it is the number of moles per liter of solution. Per liter. So
yeah.
we assume that if it is not given, so we assume that if it is 3m or 2m or 5m, whatever the number of molarity number is given, it is that number of moles present in 1 liter of solution. If it is 5m, it means 5 moles are present in 1 liter of solution. If it is
So
2m, it
sir, we
means
take that as the number.
I'm saying that the number that is given for the molarity, that it is 2m, 3m, 5m, that means that number of moles of solutes are present in that 1 liter of solution. Okay.
Yes, sir.
The total solution is 1 liter and the number of moles is equivalent to the value of that molarity in that solution. Okay. So we have 3m. 3m
Okay.
means 3 moles. 3 moles of solute. Solute means NaCl here is
Yes.
present, is present, is present in one 1 liter of solution. 1 liter of solution. Okay, now can you consider that if I'm saying that it is 3m? 3m means 3 moles. It means
3
3
moles.
moles. Okay. Now just concentrate. What is the mass of 3 moles? So 1 moles of NaCl contain 23 plus 35.5, that is equals to 58.5 gram weight. 1 mole.
Okay.
So 2 mole will be twice of this one and 3 moles will be
Yes, sir. Oh,
58.5.
you multiply it with 3. Okay.
What you will get?
1 second.
20 minutes.
Sir, 175.5.
175.5 gram.
Yes.
So it is 175.5 grams. Okay. Now coming to the point here. Now you find out the mass of solute
Substitute. So,
and you need to find out the mass of solvent.
1250. What? 1250 minus 175.5.
Yeah. So what you need to do is actually you have to subtract.
Yeah.
Okay. So you have to write that mass of solvent will be equals to 12500 minus
Sir,
what was it?
1074.5 grams.
174.
1074.5.
Your answer is this one, no? Okay. One zero
Yeah,
seven four seven four.
point 5. 74.5 grams.
Okay. Just
So
a
now we
minute.
have to find the molality of the
Yeah. Now you have to find out the number.
solution.
So how will you find out the molarity? Number of moles you know?
Sir, we have
Okay.
got the number. We
3.
have got the solution as in grams. So I think we have to convert it back to kgs because
No,
it
no
is
need.
per kg.
Yeah. So either we are just multiplying 1000 here na, for that one.
Okay.
If this is given here. You done this one?
1 minute, sir. Sir, is it 2.63?
2.63. Yeah, it can be. That is 3000 divided by 1074.
Yeah.
3000 divided by 10. How much you are getting? 2 point?
63.
Yeah, it will be approximately that. Did you do it with calculator? Honestly tell me. Use calculator? Yes.
Yes.
Why you?
Not exactly, but just for the last part because I got confused on it.
Is how you are going to solve this one. Let me help you. That is just 1000. Okay, they split it into like this way. Okay, this is
Oh, sir,
one
wait
seven.
1 minute. I just finished. Sir, is it 2.79?
No, it will be.
I'm getting a different answer now.
Okay, let me check it.
I don't know.
So this is 1 plus 7 is 8. 8 plus 4 is 12. Okay, 12. Just consider this one as 1.76 so that it can be easily divided by 3. Okay.
Yes, sir.
So you cut it, you will get 3 ones up. You will get 3 threes are 9. Then 1 carry, then 7, 3 6 are sorry, 3 6 are 18, 3 5s are 15. 3 5s are 15, then 2 carry, and then 24, 3 8s are 24, and then point. Okay, you are having here. Now this, when this number is going to divide with, okay, 3.58, you can assume this one like this way. That is 1000. Just you remove this decimal and you will get 3500. Okay. And
Yeah.
this is approximately equals to 3.5 or 3.6. You can consider this one as 3.6 because it is 82. So you can consider this number as approximately equals to 3600. Okay, upon 1200. Got it? This is the way that how can you do the calculation. And then you this you have to done in the rough. Okay, and you cut this too. Got it?
Yes,
Got
sir.
it?
Yes, sir.
And this, when you divide it, you will get 50 upon 18. And you divide it, you will get 25 upon 9. And you divide 25 by 9. You will get 2 za, 9 2 za, 18. Okay, how much you get? You will get 27.0 here. And then 2 6 za, 9 6 za, 9 7 za, 63. 7 za, 63.
Yeah.
Point and 0.
Right.
It is approximately 2.77 approx. Okay. So this is the way that you can do this easy calculation. Okay, just try to make the calculation easy. Don't get confused and with exactly what writing the values. Okay.
Okay.
So I'm going to give you this same homework in the homework that you have to do this question in the homework. Okay. Again,
Yes, sir.
let's do the other questions over this topic. One more question. Okay. Try to solve this one. First note the question in your copy and then start it.
Yes, sir.
Tomorrow might be Eid there, na?
I don't. I think so.
What is the concentration of glucose in mole per liter if 20 grams of you have to concentration in mole per liter means which concentration it is asking, tell me. Molarity or molality or mole fraction or what? There are so many concentration terms. No?
Morality.
It is molarity, okay, because it is
Yeah.
mole per liter. If it is mole per kg,
Then it
then
will
it
be
is
molality.
molality. Very good. So, okay, right. Can you tell me that what is the information it is given to you here? The concentration of means what is it asking? First of all, it is asking for the molarity. Okay, if 20 grams, if okay, this is the solute is given to you. Okay, and just 20 grams. So, what is this 20 gram? What is this 20 gram given? Tell me, what is this 20 gram
Uh,
given? Mass of
Mass. Uh,
it, you have
the
to tell me this
mass
one.
of this solute.
Yes, it is the mass of the solute. Very good. It is the mass of the solute, and that is 20 grams. Okay,
20 grams. Yes, sir.
is volume enough water to make the final solution up to 20 up to 2 liters. So what is this 2 liter given?
Volume of the solution.
Okay, volume of solution. Okay, so do it. It is very easy.
Okay. Sir,
Yes,
is the molecular mass of sugar 342
yes,
grams? Okay.
yes. It is 3.
So WB by MB by V, right?
Yeah, you can write it like this way: WB by MB into V because
Into V.
it is written in liters, so no need to multiply it with.
Okay. Sir, is it 31.31?
31.31.
No, 31 only.
31. It is only 20 grams. So 31 moles. How can the 31 moles can be present in the
Sorry, sorry, sorry. Not 31. How can it be 31? No, no, 1 second.
if you are dividing 20 with a
Yeah,
greater number, it should be less than 1.
1, yeah. Mm, So 0.02.
You cut it by 10.
Yeah.
You got 10 upon 10. Okay, you get 10 upon 43, 42. Okay.
Yes.
Just consider it approximately, that is 34, 340. Okay, you cut it, you will get 1 upon 34. Okay. 1 upon
Okay.
34 means 1 upon 33, approximate.
Nice.
Okay, you can consider it as 1 upon, or you can consider 134. Okay, you play the decimal
Yes.
here. Okay,
So
you got 0.
yeah.
Then again, you cannot read the table. Then you again place the 0
Zero.
here, one more 0.
Yes.
And you have
Yes.
to place 3 times. Okay, so when you place it 3 times approximately, if it is 33, exactly 33, it will be 99. If it is 34, it will be 102. So we are having nearest value because we have just decreased this value. Okay, it is greater
Okay.
value. So we are just having this as 3342. So it is approximately 0.03 approx.
Okay.
Next, let's move to the next concentration. Next today's topic, that is uh, law of multiple proportions. Okay, we have studied the law of chemical combination, the two laws of chemical combination that we have studied in the previous classes. Laws of chemical combination. Chemical combination. Okay, the two laws that we have studied in the previous classes. Which one? Can you tell me? Which two laws that we have studied in the previous classes? That is the law of,
Conservation of mass.
yeah, law of conservation of mass, of conservation of mass. Second is law of definite proportion. Proportion. Okay. On this topic, that today we're going to discuss the questions also on this topic. Okay. So today we shall be going to discuss the important, that is the next law, that is the law of multiple proportion. Okay.
Yes.
Just wait a minute. Let me tell you the topics of the team about your topic that I'm teaching you right now. Okay.
Yes.
Okay. So Rida, let's start. So what I'm saying here is that it is law of multiple proportion. Multiple proportion. So what does the law of multiple proportion states? That for example, uh, that there are two elements, okay,
Yes, sir.
and they are combined together, like the carbon dioxide and carbon also form carbon monoxide. Okay, law of
Okay.
multiple proportion. Proportion. What does this law say? According to this law, the weight of one element, the one element means there, for example, if I'm just saying that C, carbon form carbon dioxide also, and carbon also form carbon monoxide also. Okay. So if I'm saying that the out of the highest possible numbers that it can form, like for example, a compound can form various, the two elements can form various compounds. Like for example, nitrogen and oxygen combined, they can form nitrogen dioxide, they can form N2O5. Okay, it can form NO3, it can form N2O, it can form NO. So there can be different oxides. So nitrogen and oxygen combined together, they form this, okay, these compounds. Okay, so what I'm saying that if I fix the mass of one, like I'm just fixing the mass of one element is here, in this one is 12. Here this is also 12. Then the mass of other elements will be in the simplest ratio. In both the compound, the mass ratio will be in the simplest ratio. For example, this is carbon, and this oxygen is going to have 32 mass here,
Yes,
and
sir.
this oxygen is going to have 16 mass here. So you cut it, you will get simplest ratio, that is 2:1. Okay. Like for example, if you take carbon dioxide make carbon and oxygen make carbon dioxide, okay, and
Yes.
CO2 and carbon monoxide. Okay. So I'm just saying the simplest ratio of carbon monoxide is 12:16. Okay, and that of carbon dioxide is 12 is to 32. Okay. If suppose if I take this 2 grams of carbon, then what will be what I'm doing here is I'm dividing it by 6 to get 2 grams. So what will
Yes,
be the
sir.
ratio of this? That will be dividing by 2, you will get 8 grams this one.
Yes, sir.
No, I'm dividing it by 6. Dividing it by 6. So to get 2 grams. So let's dividing it by 6. 6. Okay. You understood? So what value are you going to get here? 2 grams. Okay.
Yes,
Here
sir.
you divide it by 6, what you will get? When you divide 16, what you will get? 6. What you will get?
Mhm.
You cut it, you will get in fraction what you are going to get here is you will get here 8 by
Two,
3.
three.
8 by 3. 8 by 3
Yeah.
grams. Okay. Here you
Okay.
divide it by 2. Again, you have to keep one element constant. Okay. Like for example, if you are getting 2 grams here, you fix. So here just 2 grams, just do the 2 grams here also. Okay. So now what you will going to get here is you'll get 2 gram here. And what is the mass of this one according to the 2 grams? So you divide it by
16.
6, you have to divide it by also 6
Okay.
by 6. So you will get uh that 16 upon 3. Okay. You will get 16 upon 3. Got it? Now
Okay.
keeping one mass constant of one element, the other elements will be in simplest ratio. How can you say? Let you divide 8 by 3 if you need to find out the ratio of this one. And it will be 16 upon 3. You cut 3, you will get 8 upon 16, and the ratio is again 1:2. Means they are also going to have the simplest ratio. Okay. They will not have means they will always have a fixed number ratio, a whole number ratio. It is not like 2.5 into 3. No, it is not like this. That. Okay. Got
Okay.
it? They will be going to have the simplest whole number ratio. So what does this law states? So according to this law of multiple proportion, law of multiple proportion, the weight of one element which combines with fixed weight of another element is always present in simple whole number ratio. For example, if I'm taking this carbon and carbon monoxide and carbon dioxide, if I'm taking the mass of carbon and oxygen here, okay, so it is 12 gram here and it is 16. It is 12 gram here and it is 32. Okay, so if this mass is constant, they both are having same
Yes,
mass.
sir.
So if both are having the same mass, then in that case, we'll simply say that this is the same mass, or mass is constant, or mass of one element is constant. Okay, then the mass of these element will be in the simplest ratio. You can check. Okay, you will get 16 divided by 32. You cut it, you will get 1:2. Okay, so they are in the simplest ratio. Got it?
Yes, sir.
Let's take another example of nitrogen oxides. Nitrogen forms 5 oxides. Nitrogen forms 5 oxides. Okay, which one? That is N2, N2O, NO, then N2O3, then NO2, and then N2O5 and N2O5. You understood? Got it?
Can you explain this?
Yeah, I'm going to explain you. This is the nitrogen oxides that nitrogen form 5 oxides. Okay. Here is the nitrogen I'm writing here, and here the oxygen. Calculate the mass of each element, that how much grams of nitrogen is present in this one, and oxygen. Can you tell me the molecular mass? How much grams of nitrogen is present in this one? Tell me, Rida. This is N2, na? N2O. N2O. So how much
Yeah,
there are two
16 in
nitrogen
oxygen.
there
Yeah.
are 16 is in oxygen. In nitrogen,
Um,
what is the molecular mass of nitrogen?
7. 7? Is it?
No, it is 14. Its atomic number is 7. So here the two nitrogen atom present, so it will be 28.
Yes, sir.
Now here one nitrogen, one oxygen means 14
14
and 16.
and 16.
Here
28
28 and
16 into 3.
48.
If 48.
Here
14 and 32.
here
Oh, yeah. For here it will be 58 and 80.
very good. Now keeping one mass constant, keeping any element mass constant. For example, you can bring this mass to 16. You can bring this mass to 14 or 28. Okay. So we are just making one mass as 28. Okay. So if I multiply this number by 2, keeping the mass, this will be 28. So it will also multiplied by 2, you will get 32. And
Yeah.
this one also make this 28. This one be also 2. This will be 64. Okay. Got it?
Yes, sir.
Now you
Yes, sir.
check that if this mass is constant, now this mass has become constant.
Yes, sir.
So the constant mass. So for a given constant mass, if an element is making various numbers of compound, okay, then in that case, we'll simply say here that they are going to have the simplest whole number ratio. Like 16 is to 32 is to 48 is to 64 is to 80. You cut by 16, the simplest ratio will be 1 is to 2 is to 3 is to 4 is to 5.
Okay.
Okay, copy this one.
We're done.
Done. The next law, if I'm talking about here, is that law of chemical combination. Second, that is next law of chemical combination is law of reciprocal proportion. Law of reciprocal proportions.
Okay.
Law of reciprocal. Just concentrate here in this law. For example, if I'm saying that there are the two elements, okay, and we are just naming A, B, A, B, okay, A and B, okay. So if I'm saying that they are the two elements and they are combining together, okay, they are having fixed weight and they are just combining together. Then if they are combining both together with weight C for an element C, okay, then the combining ratio of this one and this one will be the same of this one. Let me explain you what I'm saying here. First note it down, then I'm going to explain you.
Okay.
Okay. According to this law, the ratio of weight of AB, weight of A and B, which combines separately with a third element C, with the third element C having fixed mass. Having fixed mass. Okay. Then they will be combined in an simplest whole number ratio whole number ratio when A and B combined together. All right, noted.
Yes, sir.
Okay. For example, if I'm saying that here you see that I'm having carbon, okay, and carbon also react with hydrogen, and carbon
Yes,
also
sir.
react with oxygen. Okay.
Yes, sir.
So if I'm saying that the simplest ratio of combining of carbon and hydrogen is CH4, I'm just making this element as fixed. This is fixed element. Okay.
Okay.
Got it? And
Yes.
if they combine together, what they will form? They will form CO2. Okay.
Yes,
Got
sir.
it?
Yes, sir.
Then it will ask you in the question that what will be the formula of the compound which will form when H and O react together.
H2O.
So that would be, according to this rule, that will be H4O2, which can be further
Okay.
simplified as H2O. And when you divide it by 2, you will get this one. Okay. So if we are
Okay.
having this, but you have to keep in mind that this should be the fixed mass or
Of the
same mass,
elements.
fixed or same mass,
Okay.
same mass. Okay. Here also. Got it? Fixed
Yes.
and same mass. And it should not change. Okay. You cannot say that if you are having here C2H5 and here if you are writing, okay, so with carbon dioxide, no, it is not so. Got it? So when carbon and hydrogen combine together, like for example, if I'm saying here, nitrogen when react with hydrogen, it form ammonia, NH3. Okay. And nitrogen when react with hydrogen when react with oxygen, it form water, H2O. And what would be the compound formula of the compound which will form when nitrogen react with oxygen? And assuming that this is the constant mass. C.
NO2. NH.
NO2.
NO2.
How you get NO2?
But there is an H. But H.
I'm saying that
3
nitrogen.
minus.
I'm saying that nitrogen when combined with hydrogen, it form NH3.
Yeah.
And what hydrogen when combined with what oxygen, it form H2O.
Yes, sir.
So if I ask you that what would be the ratio of when nitrogen oxygen combined, so it will be according to this rule will be NO. NO. Like
Yes, sir.
here there was C CH4. What you write here? You write this value and this value combined together. You write H4, keeping the carbon. But here you see one thing that if I write this as this value and this value NO, this will be considered as incorrect. Why? Because the hydrogen is not constant here. Here the carbon is
Yeah.
constant. That's why you mix these formulas. Okay. But here the hydrogen is not constant. At least the mass of
Yes.
the common elements in should be same. Okay.
Same. Okay.
So it is NH3 and it is H2. So let make the hydrogen as 6. Okay, because it is 3, it is 2. So you can write this formula H2O as H6O. You multiply it by 3, you will get H6O3.
Sir, you're doing that to make the masses equal, to make the
Yeah,
masses same.
yeah, of
Okay.
hydrogens, of the
Okay.
common element that you
Okay.
have taken. Okay.
Okay.
And here also, by what number you are going to multiply to make the hydrogen
Two.
6?
Two.
2. You will get the new formula as N2S6. Okay. Now it is 6 here, it is 6 here. Okay. Then this the formula of the element that we combine together will be N2O3. N2O3. Okay.
Okay.
Do it, please. Note it down.
Sir, noted it now.
Done.
Yes, sir.
If I'm having a question here on this topic, if if compound compound AB has ratio 1:2 and compound BC has a ratio of 4:3. Okay. Then when compound AC will have the ratio of, tell me, when the compound AC is going to form, then what will be the ratio of this one?
AB is equal to 1:3 and BC is equal to 4:3.
AB is 1:2 and BC is 4:3.
Okay.
So you can write this like this way that
1/2 is equal to 4/3.
yeah, you can consider that A here. Okay. A,
Yeah.
B, C. If you are
B
taking
and
this,
then C and then you write it like that.
yeah.
So we write
So this is
1:2 and 4:3.
A, B, C. Okay. And AB ratio is 1:2. Means it is
Yes.
AB2 type compound. Okay. Okay.
Yes, sir. And then
Uh,
BC will be 4:3.
and BC is 2:3. Okay. And you know that
4:3.
it is A. Sorry, 4 is to
Same.
3. 4 is to 3. It is 4 is to 3. Okay. Then what would be the ratio of AC?
Sir, you multiply the entire both the sides by 2.
You have to keep one mass constant. Okay. If you are taking B in both, or
Oh,
A in both. Okay, so this is A, B. It is A, B. Ratio is this is A and this is B. And this is B and A. Okay, B and A. And the compound, this is BC. Okay, this is B and C. This is B and C.
we'll see. Yeah.
So
So, sir,
yeah.
can
So
you
you have to
put?
multiply. You have to multiply it by 2 so that you can make it also 4.
Yeah.
So it will be 2 is to 4. Is 2 is to 4. Okay.
Yes, sir.
So when A and C is going to combine, so it will be A and C. That will be 2 is to 3.
No, I didn't get it, sir.
What is A here? 2.
Uh,
And what is
Two.
C here? 3. It will be A is to 2 is to 3. Because
Oh, okay.
you have made the B common, na? That's why.
Okay.
Means okay, you have made the B mass as constant.
So that was okay. Yes. Yes. Okay. Understood.
Sure? You understood, sure?
Yes, sir. Yes, sir.
Okay. Let's check one more question over it, if it is
Yes,
possible.
sir.
Okay, I will give it to you now. Okay.
Okay,
Next,
sir.
next law is law of multiple proportion. We have studied reciprocal. We have studied. And the next law is Gay-Lussac's law. Okay, and it is actually for the gaseous when the reactants and products are gaseous. Okay, so we just talked about that is gaseous. Okay, so next law is the gaseous law, or we can say that law of, law for the gaseous or Gay-Lussac's law. You can say that Gay-Lussac's law. Okay,
LUSSA, sir.
yeah,
Okay.
note it down.
Yes, sir. Done.
And it is also called law of constant volumes. Law of constant volume. What does this law states? The law of constant volume, if I'm talking about, say that if the reactant and products both should be gases. Okay, if the reactant and products both are gases, then they always present in the simple ratio. The simple ratio. They are always present in a simple ratio. Okay. So what is saying that,
Yes.
for example, if I'm saying that N2 plus H2 will gives you 2NH3. So it is gas, it is gas, it is gas. Okay. So
Yes,
if
sir.
I'm saying that here, if I balance this one, this will be 2 N2 plus 3H2. It will be N2 plus chromatic shapes. Okay. So if I'm saying that N2 plus 3H2 will gives you, so here the ratio of the gases is 1 is to 3 is to 2. Got it? Understood? For example, if I'm saying that hydrogen when react with oxygen gas, it will gives you water in gas. So if I
Yeah.
ask you that the ratio, that will be 2 here. Okay, that will be, if it is gas, it is also gas. So when hydrogen burns, then the ratio of the vapor will be in the simplest form 2 is to 1 is to. Got it? The simple balance, you have to balance this, and this law is applicable for the gases only. Okay.
So basically, we have to write the balanced thing in the ratios.
Yeah. Okay.
Okay.
This is the simplest. It does not mean much. Okay.
Yes, sir.
Then next is Avogadro's law. Avogadro's law.
So then it should be 1:3:2, right?
Which one?
The first one that you gave as the example.
Yeah, 1:3:2. 1:3:2.
3:2. Okay.
Okay. So what does Avogadro's propose? He said that equal volumes of gases at same temperature, means STP, occupy equal volume, means equal mass, sorry, equal volume. If I'm saying number of moles, for example, if I'm having 1 mole of hydrogen gas, okay, and if
Yes,
I'm
sir.
having 1 mole of O2 gas, okay. So at particular standard temperature pressure, they all are going to occupy same space, okay, volume, okay. For example, if you are having a cylinder, okay, cylinder, and in that cylinder you are just filling one hydrogen gas, oxygen gas, okay. So if you are just having like if you are having a cylinder like this, and in this cylinder you are just putting the gas, okay.
Yes, sir.
And in this cylinder, if you are having hydrogen gas at particular temperature is fixed, like it is STP, standard temperature pressure, it is 0 degrees Celsius or 273 Kelvin and 1 atmospheric pressure, okay. You are just filling this gas. So if you even if you fill the gas at one, the pressure should be 1 atmosphere and temperature should be 0 degrees Celsius, then either you fill hydrogen gas, okay, either you fill oxygen gas, either you fill nitrogen gas, either you fill carbon dioxide, any gas, if you are filling inside it, their particles number will be equal. The particle numbers will be equal. Okay, the weight may be different because 1 mole of hydrogen gas has only 2 gram weight. 1 mole of oxygen has 32 gram weight. Okay, 1 mole of nitrogen has 28 gram weight. The weight can be different,
Okay.
but their occupancy will be same. Okay, if I'm saying 1 mole means that it will occupy a particular volume, and that is 22.4 liter. We're going to discuss this one. Okay, so what does
Okay.
Avogadro's law say? Avogadro's proposed like this law, and he said that equal volume of all gases, okay, at same temperature and pressure. This is important. At same temperature and pressure, at same temperature and pressure should contain equal number of molecule. You understood what is molecule? Molecule
Yes,
means, for
sir.
example, CO2. This is 1 molecule, this is 2 molecule, this is 3 molecule, this is 4 molecule, 5 molecule. Okay. So if I'm saying
Yes,
that
sir.
if you are having a container, and this container you are you are just making the other external condition fixed, like the temperature is 25-degree temperature, whatever the temperature you are taking, let's it's your choice. Okay. So if I'm saying
Okay.
that if you are keeping all the gases in that container one by one, okay, at the same temperature, they will have the same number of particles. Their mass can be different, okay.
Yes, sir. Yes, sir.
Okay. But equal volume of gas at same temperature, okay, contain equal number of molecules. We can say that according to him, okay, 1 mole of gas occupies 22.4 liter 22.4 liter volume at STP, standard temperature and pressure. Okay, that
Okay.
1 mole of any gas. For example, if you take 1 mole gas means like 1 mole N2 means 28 gram. Okay, the 28 gram, if you take 28 gram nitrogen, okay,
Okay.
if you take 28 gram nitrogen, 44 gram carbon dioxide, 2 gram hydrogen, 2 gram hydrogen, okay, 32 gram oxygen gas, okay, and like CH4 is 16 gram, any gas you are taking. If I'm saying
Yes, sir.
that it is they all are 1 mole, this is 1 mole, this is 1 mole, this is 1 mole, because it is equal to the 1. So 1 mole means 6.022 into 10 power 23 particles, okay. So all of this 6.022 into 10 power 23 particle will occupy 22.4 liter space, okay. So they will occupy 22.4 liters, okay. So if I'm saying that uh, why the hydrogen fuels, why the hydrogen cars is not, I mean, we are not able to fill the hydrogen gas, okay. Or we can say the vehicles that are using the hydrogen, like you see that in Delhi, CNG, compressed natural gas, is used in the as a fuel, okay.
Yes, sir.
But if I'm saying that 16 kg, if in a cylinder 16 kg of gas is coming, methane gas CH4 is coming, then in the same cylinder only 2 kg of hydrogen gas will come in the same cylinder, okay. In the same cylinder,
Okay.
44 kg of carbon dioxide can come. In the same cylinder, 32 kg of oxygen can come. So since the hydrogen molecular mass is very less, so only the 2 kg of hydrogen will come, okay, in that same cylinder in which the 16 gram of methane gas is coming. So simply we can say that's why this is the main reason that since we need to use bigger tank for storing the hydrogen gas, because only 2 kg of 2 or 3 kg gas of hydrogen will come in a big cylinder, okay. So this is very less amount of fuel that we are going to use, so that's why, okay, you understood. So equal volume of gas occupy, you will not, if you are not if you are getting stuck somewhere, let it be, let's do some numerical problem, then it will be okay for you, okay. You will
Okay.
understood the concept, don't worry about it.
Yes.
Let's do this question first.
Yes, sir.
Dinitrogen react with high hydrogen gas to produce ammonia. According to this reaction, there should be 3 hydrogen here. Misprinting.
Sir, should I
Calculate.
write down the question first?
Yeah, yeah.
Okay.
This is might be on the limiting reagent. So what is saying that dinitrogen
Yes, sir.
H2 when react with N2, it will gives you NH3. So what it will going to give you? It is, okay. Now, if I'm saying that, it is saying that calculate the mass of ammonia produced when this 2 kg. Okay, now it is 2 kgs. This one is given to you 2 kg, and this one is given to you 1 kg, then how much gram of ammonia is going to produce? This is on the limiting reagent questions.
3 kgs.
So what you will do for this one? You remember limiting reagent?
Where is it? 3 kgs. When you add the
No,
total.
you forgot. You forgot. This we have learned. Okay, just concentrate here. What is the simplest ratio of nitrogen and hydrogen in ammonia? NH3. This is the formula for ammonia.
Yeah.
Okay, and if this is the formula for the ammonia, you will notice here that nitrogen is 14 and here it is 3. Okay,
3. Yes, sir.
so ratio for this one is 14. I'm
3
just
is to
writing
3.
nitrogen here. Okay, 3 here. If I'm writing nitrogen here and hydrogen here, then it will be 14 is to 3. Now it is hydrogen is nitrogen written here, that is 3 is to 14. Okay,
3 is to 14. Okay.
and it will give 17 grams of this one. Okay,
Okay.
now you are given 1 gram 1 kg. So if it is in gram ratio, so it will be also in kg ratio. Got it?
Okay.
Okay, the ratio does not require in units. So if I'm saying 1 kg here, then it will be, if it is 2 kg, then which is the limiting reagent?
2 kgs. Oh, like that. Okay, okay. Understood, understood. Yes, sir. I understood. I remember now. So 14. Yeah.
Means this one is the limiting reagent, na?
And 2. And 2,
Here
yeah.
you get 6 as a product, here you get 14. So where you get
Yeah. The more
less,
number is
the more number it is the less limiting reagent.
limiting
Okay?
reagent. Yes, sir. Yes, sir.
So the product will be formed according to this, because this will be consumed first. Okay, the product will be
Yes,
formed
sir.
according to this one.
Yes, sir.
Okay, so what we will do, we will remove this value.
Okay. Yes. And add X.
Then what you will going to do? You will get 3 upon x is equals to okay, and here you can, since it is asking for the, it is not asking for the nitrogen, so you can equate these two also. You can write it like this way: 14 upon 2 is equals to 17 upon y. You can calculate directly the value of y, because it is asking how much amount of nitrogen. But it is also
Oh, okay.
it is also asking how will any of the two reactant remain unreacted, and if yes, then what would be the mass? So it is, so we need to find out the mass of hydrogen also, the unreacted one.
Then you have to do it. The number
Yeah, we have to do this one also. 14
okay.
by 2.
3 by 7. That is.
Now you get 7 here. Okay, you will get x, you will get 3 by 7
Yeah.
kg of hydrogen will be actually used. Okay,
Yes, sir.
so an amount of ammonia gas will be formed by, you can write it 3 by 7 plus 2 kg, because this will be consumed first, and this is the only
Yes,
3 by
sir.
7 kg amount of. So you can add these two either, or you can find out the value of y, that will be also equal. You can find out the value of y will be equals to, this is 7, so there will be 17 upon 7. Okay, so
Yes, sir.
how much you write it? 7, sorry, 3 here and 7 here. So you will get decimal 0, and then 7 3 the 7 4 the 28. Okay, then 2, and then 0. Okay, then 7 3 the 21, approximate 21. Okay, so
Yes.
you can simply say that out of 1 kg, only, if we just converting, this is in kg. So if you convert this one into grams, you have to multiply this one by 1000.
Yeah.
Okay, so that will be 430 grams. Okay,
Okay.
so out of 1000 gram that is given to you here, hydrogen, only 430 grams of 430 grams will be consumed. Okay, remaining 570 grams will be remain unreacted. Okay,
Yes, sir.
and similarly you can convert it into kg also here. So 17 divided by 7. If there's a 7 to the 14, we'll get 2 here, 33 here, and then point decimal, then 7, 7 4 are 20, 2.4 kg. 2.43. Okay, the same 2.43, or you can get 2 kg and 40. You can get 2,430 grams. Because 2 kg, you convert it into grams, and this you have to add also. Okay, got it? Are you sure that you will be able to do this one properly in your notebook?
Yes, sir.
Is there any confusion? No?
No.
One last question. In the reaction, it has been given to you that A when react with B2 will gives you AB2. Okay, identify the limiting reagent if any. So you are having this one A and this one as B2 and this one AB2. Okay. Simplest ratio for this combining ratio is that one atom A of A combined with two atoms of B to form AB2. Okay.
Yes.
You can also write the ratio of the, it is not, if it is given the ratio of molecules, then you can write the ratio of molecules also. If it is given the mass, like in the previous question, the ratio of mass was given to you. No?
Yeah.
The mass was given to you. So you write the ratio of mass, kg, 14, you write 3:14, okay? This is not the, if it is the number of atom is given to you, then you will write N2 plus 3H2 will gives you 2NH3. So you will write the ratio that 2 nitrogen atom react with 6 hydrogen atom. You can get 1:3. Okay.
Yes.
So this is the number of atoms ratio. So when the number of atoms are given to you, then you have to write the number of atoms ratio. And when the mass is given to you, then you have to write the mass ratio. Okay. Got it? For example, the same question N2 plus 3H2 will gives you 2NH3. Okay. If instead of this one in the previous question, if it is given to you that that if 300 atoms of 300 atoms of nitrogen is reacting with 200 atoms of hydrogens, then how many nitrogen ammonia molecule will be formed? So what you are going to do here is that simply you will write the number of atom ratio. So 2 atoms combines with, or you can write NH3. Simple, 1 atom of nitrogen combined with 3 hydrogen. So you will write 1:3. It's a number of atoms ratio. Okay. Okay.
Okay. Yes.
Then again, so here, but if the mass was given, then you have to take the mass ratio.
Yeah.
Like 14. This is now, this is the simplest ratio for this one is 1:2. And this is the 300 and this is the 200 of B. So which is the limiting reagent?
300.
You just multiply this one and usually where you get the product, more product. You will get 600 here, na?
Oh, okay. Yes, sir.
So this is the limiting reagent, okay?
Yes, sir.
Now the same number of moles. Okay, now just you need to concentrate here that it is B atom and B molecule. What is the difference between O and O2? If I'm saying that it has 1 mole of O, 1 mole of O, it is 1 mole of O2. Okay, and if I'm saying that it is 1 mole of O and it can be written as 2 mole of O, 2 moles of O. Okay, because it is O2. So if you are adding only O, then it is 2 moles. Like in N2, it is 1 mole of N2 gas, nitrogen gas. If I'm asking how many moles of nitrogen is present in this one, 2 moles.
2 moles.
Because, okay, so difference between moles and molecules is that N2 is molecule, N2 is molecule. Because it is 2 atoms combining together. Okay, so just concentrate here. If I'm saying that 100 atoms, it is saying atoms, and here it is saying molecules. Okay, so atoms is to molecule ratio is, so you see here that you see that one atom of A combined with 1 molecule of B. This is 1 molecule. B. This is 1 molecule. Okay, got it?
Yes.
So 100 atoms of A combined with 100 molecule of B. Okay. So the ratio is 1:1. Molecule, because it is a
Okay.
molecule. Okay, not, you don't write 2 here because it is not saying atoms. If it is saying atoms, 100 atoms of A react with 100 atoms of B. So it means we have to write the ratio of atoms. So atoms will be 2. So then there will be 2 atoms of B will be required. Okay. But it's not saying atom. It is saying B molecule. So you have to write 1. You're getting?
Molecules they have written.
Yeah, they have written molecules here. No? Let me explain
Yeah.
you one more time. Like for example, if I'm saying sodium when react with oxygen gas, it will gives you Na2O. Okay.
Okay.
So in the formula, if I'm balancing this one, okay, so 2 and here we'll write here, okay, this is the, now I'm saying that 2 atoms of sodium combines with 1 molecule of, now it is balanced now, 1 molecule of B. 2
Yes, sir.
atoms of Na, okay, 2 atoms of Na combines with molecules of O2. Okay, or O, one molecule, if it is in one molecule means O2. Okay, and if I'm saying that 2Na plus O2 will gives you Na2O. So if I'm saying here that two atoms of sodium, 2 atoms of sodium combines with 2 atoms of oxygen, 2 atoms of oxygen. Okay, so if I'm saying atoms, then it will be 2 atoms of oxygen. If I'm saying how many molecule are there, there will be only 1 molecule of oxygen. Okay, you understood?
Can you explain again?
I'm saying that sodium is 1 atom. The 2 atoms of
Okay.
sodium combined with O2, then they will form Na2O.
Yes, sir.
Okay, for example, in this one, and if I'm saying 4, now it will be 4 because actually this will be 4. Okay, just stop. So if I'm saying here that N2 plus H2 will gives you NH3. Okay, NH3.
Yes.
So we'll say that if I balance this one, so this will be N2 plus 3H2 will gives you 2NH3. Okay, this is the balanced chemical reaction. So I'm
Yes,
saying
sir.
that 1 molecule of N2, 1 molecule of N2 combines with 3 molecules of H2 to give 2 molecules of NH3. Okay, got it?
Okay. Yes, sir.
Same can be written as that 2 atoms, because in one molecule
Okay.
there are 2 atoms. 2
Yeah,
atoms
yeah,
of
yeah. Yes,
and
sir.
nitrogen combines with 6 hydrogen atoms. 6
Okay.
hydrogen atoms to gives 1 molecule. Sorry, 2 molecule. 2. Here we cannot write atoms because this is a heteroatoms. No? So atoms
Yes, sir.
cannot be written. So 1 molecule. So in the previous question, if I go to this one, and if I say that it is saying 100 atoms of A and 100 molecules of B. So B2 is molecule. Okay. So the ratio will be
Okay.
1:1.
Okay.
So if I'm thinking 100 to 100, so there is no limiting needed. They both will
Yeah.
combine. They will, okay. Okay,
Yes,
because
sir.
1:1 ratio. But in
Yes.
the above one, let's just say 2 more.